This is Unit 7, Lesson 2, Properties of Quadrilaterals, Day 2. Let's talk for a minute about the interior angle measures of a couple of figures. In a triangle, the sum of the interior angles, that is those three angles on the inside, it's 180 degrees. That's something you've learned already. You may or may not know what the sum of the interior angles of a quadrilateral is, but we could figure it out based on what we know about a triangle. If we were to draw the diagonal of this quadrilateral, it would cut it into two triangles. So we know that the interior angles of this one triangle is going to be 180 degrees, as is the interior angles of that other triangle. So you can see those six angles taken all together form the four angles of our quadrilateral, so 180 taken twice is 360. So we know that any quadrilateral has interior measure angles that add up to 360. So we can use that information to determine the missing angle measure if we've got some of the angles of our figure and one is missing. So in this first case, we've got 60 and 40. Add those together and get 100. Subtract from 180, we get 80. So we know that the missing angle measure is 80. Now you can see that most of these include the degree symbol, but it's understood that we're working with degrees. So going forward, we can just write the angle measure without putting the little degree symbol, and that's okay with me. There's another way we could have done this problem, because you know that I love using algebra. So it's possible that we could have solved it with an algebra equation, showing that the three angle measures, 60, 40, and the missing one called x, add up to 180. And then we could solve that equation to isolate x and find that x is equal to 80. So either of those are perfectly good ways of finding that answer. Taking a look at B, we just see one angle measure there, 30, but you can see that the other angle is a right angle because of the markings on the figure. So we know that that has a degree measure of 90. So doing our same process, we can figure out that that missing angle measure is 60. Don't forget to be writing down all these steps on your note sheet as you watch. In the last case, we've got a different situation, slightly different because it's a quadrilateral. So instead of subtracting from 180, we know we have to subtract from 360. So in this case, our missing angle measure is 70. Go ahead and try the next three on your own, and then come back and see how you did. All right, here are the answers. All right, now we're going to do something a little bit different. We're going to use what we know about each type of quadrilateral that we learned earlier today in class to determine additional information about a figure. Okay. So you can refer to today's note sheet that gives you the properties of all the quadrilaterals whenever you need to. But eventually, you're going to have this information memorized. All right, so instructions say determine the measures based on the information given. But if there's not enough information to know the answer, you're going to write NEI for not enough information. All right, example 2, we're given that PTDM is a square. So what I often do, and what you're going to do along with me on your note sheet, is to mark the figure with the information we know. So if we're told this is a square, right off the bat, we know that it means it has four right angles. So I'm going to show those markings. Then it tells us that the length of TD is 11.3. So I'm going to write that in on my figure as well. But because it's a square, I know those other side lengths are the same measure as well. So I'm going to go ahead and write those on the figure because I know that information. So go ahead and write those on your figure as well. Then it tells me that PE is 16. So I can go ahead and write a 16 alongside the segment PE. Then I know that the diagonals of a square bisect each other. So I know the length ED is also 16. So I'm going to write that in there too because I know that. While we're thinking about diagonals, I realize that the diagonals are equal in measure in a square. That's one of the pieces of information we learned today, so that I know that the diagonal MT is also made of two pieces that are cut into 16, so I'm going to put those on there as well. And I remember that the diagonals of a square or rhombus meet at 90 degrees. They meet at right angles. So I'm going to show right angles for all of those 4 angles where my diagonals intersect as well. Now that I have my figure all marked up, let's go and see what the question is asking. What's the length of MD? Well, I look and see right there that it's 11.3, so I can write that in. PD. PD is the entire diagonal, and I can see it's made of 2 parts that are of the length 16, so we add those together, and PD is a length of 32. MT is my other diagonal, so I know it's going to be the same measure. That's also 32. All right, the measure of angle PDT. So that's something you have to figure out. I'm sorry, I misspoke. PTD. So we're talking about this angle right here. PTD, that's one of the angles of our square, so we know that's 90 degrees. Now it's asking about PET. PET is one right here, PET. So that's this angle right here, and that's one of the angles where our diagonals meet. We know that's also 90 degrees, so I can write that in there. All right, example 3. Given that BDGH is a parallelogram. So if I know it's a parallelogram, I know that the opposite sides are parallel. So I can show that marking with the little triangles on each set of opposite sides. Now it tells me BD is 30. I'm going to write that in. But I also know if BD is 30 that the opposite side is the same length, so I'm going to write in 30 down there. Now it tells me that BG is 36. So I'm going to indicate that, but you see that I've shown my lines on there showing that it's the entire length BG. If I just wrote the 36 next to that line, it might be hard to tell if I was talking about BA or all of BG. So it's important that you show it means that entire length there as I showed it. Then it tells us the measure of angle BDG. Let's take a look. That's BDG. So we're talking about this entire angle measure right here. Now you can see that angle D, there's actually 3 angles going on right there. The little one that are created by the diagonal and the entire one. That's the angle of the parallelogram. So it's important when we go to mark it that we use the marking showing that it's that full angle is 71, so we know which one that we're talking about. If I know that's 71, then I know the opposite angle in the parallelogram is also going to be 71, so I'm going to mark that as well. All right, now let's see what they're asking. GH. GH is that lower side, and we know that's 30. We've already got that marked. BH. BH is that side along here. It doesn't tell us what measure that is, so there's not enough information in this question that lets us know that answer, so we're going to write NEI, not enough information. Now it's asking about the length of BA. This is a parallelogram, and we know that the diagonals of a parallelogram bisect one another. Therefore, we need to take the length of 36 and cut it in half, and we know that BA is actually going to be 18. Now it's asking about DH. DH is the other diagonal. However, the diagonals of a parallelogram are not necessarily the same length. So we don't have enough information to know that, so we're going to write not enough information. BAD. BAD is the angle measure here where the diagonals are meeting. We don't know anything about that. They don't meet at a right angle in a parallelogram unless it's a special case parallelogram and is in fact a rhombus or a square. So there's not enough information there. The measure of angle BHG. BHG is that one that's opposite from the 71 degree angle, so we have already determined that's 71 degrees. The measure of angle HGD. HGD. Okay, so that's one of the other angle measures of our original parallelogram. And we weren't told that measure, but in fact we can figure it out. We know that 2 of the angle measures are 71. So if I add that together, we can get 142. Subtracting from 360, that leaves me with 218. So I know those other 2 angle measures of our parallelogram, angle B and angle G, add up to 218. But because it's a parallelogram, we know that those angle measures are equal. So if I divided 218 in half into 2, I'd know that each of those angle measures are actually 109. So we can write in that those are 109. Then we want to know if BH is parallel to GD. Side BH and GD are opposite from one another. So the answer is yes, they are parallel. Example 4. Now we're given a trapezoid, and it tells us which are the bases, which two sides are parallel to one another. And so I'm going to mark that on my figure, MR and NP. It tells me PA is 8. I can write that in. And MN is 30. I can write that in. And then it tells me the angle MNP is 52. So I can make all those marks on my figure. Let's see what it's asking. RP. RP is the length of a side. We don't know enough information here. We know it's not going to be the same as MN unless we're told additional information. And so our answer is not enough information. PM, that's the entire diagonal. We know that PA is 8, but in a trapezoid, the diagonals do not bisect each other unless it's a special case situation and we're not told about anything special going on here. So we can't make any assumptions about MP and how it relates to the two pieces. So we're going to, again, have to say not enough information. PAN. PAN is one of the angle measures formed by the diagonal. We know that they are not 90 degrees unless it's some kind of special situation. We don't have any information like that, so we're going to say not enough information again. And then we want to know if MN is parallel to RP. And we know it is definitely not, because a trapezoid is defined as something that has exactly one pair of parallel sides, and the other set are parallel, so the answer here is no. All right, that's it. We're going to do lots more problems like this in class with all of our quadrilaterals. Put your note sheet in your binder, and I'll see you tomorrow.